Programming in cars, why it matters.
Modern vehicles rely heavily on software to control engines, safety features, entertainment systems, and even autonomous driving. As car technology evolves, programming languages play a vital role in shaping the future of automotive innovation. Understanding which languages are used helps open up rewarding career paths for anyone interested in vehicles and technology.
C and C++, the industry backbone.
C and C++ have been cornerstones of automotive software for decades. Their speed and efficiency make them ideal for real-time mission-critical applications like engine control units and braking systems. Automakers trust these languages for their reliability, widespread industry support, and ability to interface directly with hardware components.
Python, accelerating innovation.
MATLAB is increasingly popular for rapid development and prototyping in the automotive sector. It's widely used in areas like test automation, data analysis, machine learning, and simulation. Python's simple syntax and extensive libraries help engineers experiment quickly, especially when working on advanced features such as autonomous driving algorithms.
MATLAB and Simulink, modeling the future.
MATLAB and its companion tool Simulink are invaluable for mathematical modeling and simulation. Engineers use them to design, test, and verify automotive systems before physical prototypes are built. These tools are essential in the development of control systems and signal processing applications across the industry.
Other emerging languages.
Java, Rust, and embedded scripting languages are finding their place in modern vehicles. Java powers many infotainment and connectivity solutions, while Rust is explored for its safety and security features. Scripting languages like Lua may also be used in certain embedded systems, further broadening the skill set needed in automotive software engineering.
Launching a career in automotive software.
A career in automotive programming calls for strong skills in C, C++, Python, and modeling platforms like MATLAB. Experience with embedded systems, real-time computing, and safety-critical development is highly valued. Stay adaptable and curious, as the technology landscape shifts rapidly, with new languages and tools shaping the vehicles of tomorrow.